The next portion of our study of carboxylic acid reactions is going to be the hydrolysis of the esters that we just made. In order to do a hydrolysis, we're going to add water and we're going to break a bond. In the case of the hydrolysis of an ester, we add water. We also need to have an acid catalyst, which isn't shown right here, and that's because we can do this reaction in a couple of different ways. But we need to add water. In this case, we need to have an acid catalyst, and we end up breaking the ester bond. So we break the ester bond, and we end up back with our carboxylic acid and our alcohol. In this case, we have ethyl acetate, so ethyl is the branch that becomes the alcohol, and it becomes ethanol. The acetate is what was the carboxylic acid, and it becomes acetic acid. So this is a hydrolysis of an ester. So the first reaction that I'm going to show, and I'll draw an example of this in just a second, but is what we call an acid catalyzed hydrolysis. And that's the reaction that you just saw on the previous page. And now I'm showing that we have an acid catalyst. You did an ester hydrolysis in the lab, but yours was a base catalyzed hydrolysis, and we'll show that in just a moment. So with an acid catalyzed hydrolysis, we take our ester and we break the ester bond, and we end up with ethanol, and we end up with benzoic acid. So this is our benzoate, and we end up with benzoic acid. So let's look at an example of an acid catalyzed ester hydrolysis. So if we're going to do an acid catalyzed ester hydrolysis, we need to start out with an ester. So I'm going to start out with ethyl butanoate. Ethyl butanoate. It's probably a little easier to start out with the butanoate part, so I'm going to draw that. But is 4 carbons. So I have 1, 2, 3, 4. On the first carbon, there is a carbonyl, the carbon-oxygen double bond. Then there's going to be the ester linkage, and the branch on the ester linkage is going to be a 2-carbon branch, 1, 2 for ethyl. So this is ethyl butanoate. What we're going to do is we're going to add water in the presence of acid. The bond that we're going to break is the ester bond. So we're going to break that bond. From the water, an H will attach to this O to make ethanol. So we make ethanol. And the OH will attach to the carbonyl right here. And we will end up with butanoic acid. So this is butanoic acid. And so now we've done an acid catalyzed ester hydrolysis. We take ethyl butanoate, we break the bond, we get ethanol, and we get butanoic acid. The other kind of hydrolysis that we can do is what we call a base catalyzed ester hydrolysis. This is also called saponification, and it's the reaction that makes soap. So in order to do a base catalyzed ester hydrolysis, we still have to add water. And where the water comes from is this aqueous conditions, okay, which means there's lots of water around in order to make the reaction happen. We also need to have a base. So in this case, we have sodium hydroxide, and we also need to have heat. The resulting carboxylic acid is the same thing. And we're also going to end up with an alcohol, but the way that we get there is a little bit different. because we're in basic conditions, our carboxylic acid is going to donate the H to the base. Okay? It's going to lose the H, and it's going to become a carboxylate ion. And then the cation from the base will combine with that carboxylate ion to make a carboxylate salt and the alcohol. So let's look at an example of this. So now we're going to do a base catalyzed ester hydrolysis. And I'm going to do this base catalyzed ester hydrolysis on methyl benzoate. I'm going to draw my benzoate portion first. This is a benzene ring, which means it's an aromatic ring connected to the carbonyl. And then I have my oxygen, which is the ester bond, and a methyl group, so simply one carbon. What we're going to do is we're going to add aqueous NaOH. And so that provides the water. In addition, we have to have heat. Now, I'm not going to write the NaOH as a catalyst because it is here as a reactant. We do need to have heat, and you'll recall that in the lab when you did this reaction, the saponification reaction, you had to heat it. So the heat is an important part here. So what will happen? Well, we're going to break the ester bond just as we did in the acid catalyzed hydrolysis. And I'm going to show this in a slightly simpler way, which I recommend that you do also. We're going to make methanol. So we're going to make methanol. So this is our one carbon with the alcohol. And then we're going to make our benzoic acid. So we've done our hydrolysis, and we have our carboxylic acid and our alcohol. But now that we have this carboxylic acid, we look back and we see, oh, it's in base. All right? This is, after all, an acid. So it's not going to exist as an acid. How it's going to exist is as a carboxylate ion, because with strong base, this acid will give up the H. So what we will have is a benzoate ion. So once it gives up the H, it becomes negative. We're going to make water. And we have the Na plus available for it. And so what we will call this is sodium benzoate. So what we've done is a base catalyzed hydrolysis of an ester. We break the ester bond. We form our benzoic acid and our methanol. However, benzoic acid in the presence of a strong base will break up, will lose its H to make water, and then we will get our carboxylate salt, sodium benzoate. So the upshot is that we make a carboxylate salt and an alcohol. I just want to go over very quickly what happens when you put a carboxylic acid in water. If we take any carboxylic acid with water as a base, it's going to have an equilibrium. Right? It's going to have an equilibrium because carboxylic acid is a weak acid, water is a weak base, and we will make a carboxylate ion and some H+, okay, or hydronium ions. If we take a carboxylate ion, which we have here, and we add it to water, it's going to have an equilibrium, which means there's going to be some carboxylate ion, there's going to be some carboxylic acid, and some hydroxide. So the question is, what happens if we put an acid, like carboxylic acid, in a strongly basic solution? And what you saw is what I showed in the base hydrolysis of a carboxylic acid. And that is that the carboxylic acid loses its H to the OH. And so I'm going to redraw this with just a simple carboxylic acid. So I'm going to use R. So a general carboxylic acid plus NaOH. And what will happen is that the carboxylic acid will lose its H and form water. And we will form a carboxylate ion that will be balanced out by a sodium ion. And what you'll notice is that this is a single arrow. That means that because it's a strong base reacting with a weak acid, it's going to go to completion. So if you put a carboxylic acid with a strong base, you will always end up with a carboxylate salt. And this is an example of a neutralization reaction. We have an acid and a base, we make a salt and water.